All right, good morning everyone. Nice to see so many of you managed to get here after the party last night. So I guess this is like the keynote of the second day, no? Anyway, so this is going to be a quite non-technical talk to let all that caffeine sunk in before we move on to more technical talks. Before we begin, just a few words by myself. So during the day I work at a company called Umbra in Finland. We do 3D graphics optimization. I have a short video here to share. So what we do is we take these huge 3D models and we optimize them in our cloud-based computing system so that they can run in real time on various devices in augmented reality, in virtual reality, and so on. But then during the night, which is actually quite long in the winter of Finland, I do a lot of open source work in Scala. And one of those things is this ScalaFiddle. So how many have actually used ScalaFiddle, the service? All right, quite many. Maybe even more after this talk. So what is ScalaFiddle? It's basically an online service where you can create, share, compile and run Scala code, sort of short Scala code snippets at this address. But it's also an embeddable web component, so you can take the ScalaFiddle out of the editor and embed it into other web pages, which makes it quite useful for many different use cases. So this is what it looks like on the website. It sort of follows the layout of other fiddle services like JS Fiddle and so on. So on the left side you have some information about the fiddle that you are working on. You can choose some libraries. Then you write the code in the middle, and then when you compile it and run it, then the results will show on the right side. There's another service like this called Scasti, which works pretty in a similar fashion, except the code is typically run on the server side. Here, when we are running it in the browser, we can also use the browser features like the DOM to create HTML. Then if you want to embed it, it looks a bit different, more optimized, so that you can just fit it into a blog post or some other place more easily. But basically it has pretty much the same functionality as the website itself. So just a quick look at how it works. It's basically split into these couple of modules. There's the editor, that's just a web application built on Scala.js and Play, which is the visible client to the users. Then all the requests go through this content distribution network for performance reasons, and then there's a router that routes all the compilation requests to these different compilers running on the same server or on multiple servers. And the thing is that it just doesn't compile the Scala code, but it compiles it to JavaScript, so using Scala.js, as we heard actually yesterday. Jarek was presenting Scala.js, and he was actually using this kind of similar system of compiling to JavaScript on the server and then running it in the browser. So this is how it works underneath. But today we are going to be talking about a couple of different use cases where you can use ScalaFiddle. So the first one is doing quick experimentations, that you want to try something out quickly and you don't want to create a new SBT project and all that stuff, but you just want to experiment. The second one is exploration of libraries and other features. Again, you can just go to the ScalaFiddle and try out different things, learning about those libraries. Third is about more like learning Scala and its libraries, how ScalaFiddle can help there. And the last use case is building interactive documentation using ScalaFiddle. So let's begin with the experimentations. I think this is probably the most commonly used way of how people use ScalaFiddle, is that they go to the site and put some code in there, compile, run it, do a few iterations to see how things work. And the reason why people do this is that it's usually even faster than editing and running locally. So especially if you need to do an SBT project and run it through SBT, it's definitely a lot faster. But it's also typically a bit faster than doing a worksheet in IntelliJ or using these REPLs and so on. And of course, because it's a full screen editor, it's much easier to edit the code than in these REPLs that are quite commonly used as well. And finally, you can share your fiddle with colleagues and other people to get their feedback and advise what you are doing. So let's take a quick look at what it could be. Let's make the screen a bit bigger. Okay. So this is a problem I had recently when I was actually adding support for JavaScript libraries for ScalaFiddle, that I basically have these JavaScript dependencies that have to be loaded in the correct order, and each library might have its own dependencies, and then when you're using multiple libraries, you have to figure out how to load all those libraries in the correct order. So this is basically sort of showing how the data originally looks like. And so I went to Google around that, okay, what kind of algorithm would solve this problem. I found out about this topological sorting, and somebody had been happy to help me by providing this kind of a gist that does exactly what I wanted. So with ScalaFiddle, I can just go and basically copy paste this whole thing here and go back here and put it in there, and then I can just run it. And I can see the errors very quickly. I don't have tail recursion annotation. I'll just remove it. And here I'm actually running ScalaFiddle locally just to make sure that things actually work in case there are some network problems. So it seems to be working just fine. Of course, my list is not in the correct format, that I should be producing these tuples, sort of tuples describing the different dependencies. So I need to write something here, but instead of writing it, I'm just going to copy paste it from something I did previously. So this is just a way of converting those lists into individual tuples that describe the dependencies. So now I'm just going to remove this stuff here that was in the example, and I'm going to replace it with the pairs that I provided. And boom, I have almost working system that figures out the correct order of the dependencies. I just need to filter the one empty entry. Whoops. I can't do it there. After the sorting, yes. And now it works fine. So this is a good way to sort of experiment with code that you get from some other place, and before you actually go and put it into your own code base, because it might be difficult to test it there, or not difficult. You can always, of course, write tests, but it takes a lot of time to go through those iterations using normal testing. So here I had to add this kind of a single entry in the beginning of lists, because in some cases there is just one dependency and you can't create a pair out of a single dependency. So that's a sort of a simple use case of doing experimentations. Then let's move on to exploration. So this is more about sort of finding out about libraries and their features instead of just solving a problem, but you just are interested in some library and want to figure out what you can actually do with it. And ScalaFiddle makes it quite easy to try out these new libraries. There's a new feature coming that the libraries can actually provide a code sample to get you started, so you don't just get this kind of a blank page where you have to start writing your code, but you actually get something you can use directly. And ScalaFiddle has autocomplete, so you can just press Control Space to get completion suggestions, just like in any editor. So that also helps in exploring the various things you can do with these code bases. So let's take a look at another thing. So Scala.js React is a wrapper for the sort of popular React library on JavaScript. It makes it easier to build user interfaces using Scala.js and the React library. And it comes with a few live examples and that we can take a look at here. So this is, for example, you can do stuff here, and you can see the source code here and so on. But of course, you cannot currently do it interactively, so we need to again go and copy it somewhere. I've actually done it here already, but let's put it there again. I added this import, which was missing from the example, and now I have selected this library here. So in this local installation, I have a very limited set of libraries, just trying out a few things here to keep it simple. And now I can compile, but it doesn't compile because I don't have a mount node. So ScalaFiddle exposes some things locally. For example, this panel, which represents the panel on the right side. So if you want to add some HTML, you can just use fiddle panel to reference that location in the DOM. And now I have this functional to-do thing here. And now I can start experimenting. I can do things like change the header and compile it again. I get a bigger header. I can do all kinds of things, just trying out React locally here inside ScalaFiddle. So this is one of the features that's not currently available in the scalafiddle.io site yet. It's coming there hopefully in a few days, but it works quite nicely. And there will be other libraries, JavaScript libraries available as well. So imagine that you have let's say you have a team of front-end developers doing JavaScript and you want to get them trying out Scala.js using libraries that they sort of already know, and this is a very good way, very easy way for them to try out some things. So you could prepare some simple fiddles for them and just let them play around with it. They don't have to take the pain of SBT and all that initially, but get this kind of a easy way to get started on Scala. So let's take a look at another example here. Let's actually refresh that. So D3, so this is a data management library on JavaScript, very popular for all kinds of visualizations. And here I have now added this kind of a sample that I can just start exploring D3 by loading this sample. So this is already prepared for ScalaFiddle, and I can just easily run it here. So then I can go and do some experimentations, like let's change the color to something else. Okay, that was probably not correctly spelled. Who knows how to spell fuchsia? Let's put something else there, green, and that should work fine. And now it's getting brighter on the right, and I can see that this is a color, so I can use autocomplete to see that what else can I do with this color. So I get all these suggestions that, okay, there's also darker, so maybe I'll enjoy darker colors more, and I can do these experimentations, changing the values. And as you can see, the iteration cycle is really fast, considering that it actually sends the Scala code to the server, which is of course running locally now, and it compiles the Scala, it compiles to Scala.js, sends the JavaScript back to the browser, and then it runs it locally. And as you can see, it's pretty much immediate. So no, again a sort of point that people sort of make that, okay, Scala is so slow to compile, and it's SBT slow and so on. So again, if you present Scala to, let's say, JavaScript developers using ScalaFiddle, they get this kind of good experience that, hey, actually it's pretty fast. And then later on they realize that it's not actually that fast. So if you use shapeless in ScalaFiddle, it's going to be slow anyway. Can't help with that. Okay, moving on. So what about then learning? So all these three first things are a bit about the same thing. It's experimentation, learning, exploration. It's all the sort of same thing, but I split it up into these different themes a bit. So like I said, it's very easy to get started with ScalaFiddle. You don't have to install anything. The compilation is really fast. It's platform independent, so even if you're using Linux, Mac OS, Windows, it doesn't matter. It's as easy to get started because you just need a browser. Then if you really want people to start learning, you can integrate these interactive ScalaFiddles onto web pages or your blogs or even some forum posts so that you can get people started on experimenting and learning Scala using ScalaFiddle. And quite often, if you are in a Gitter channel for Scala, you see people asking for help. They are just pasting some code into the chat and asking people to help, but it's a lot easier to create a ScalaFiddle sort of demonstrating your problem and then just sending a link to the chat and asking people to help there, and then they can go and edit the ScalaFiddle and produce working solutions and so on. Let's look at a short example. So this is actually the main Scala documentation page, and there are some integrated fiddles in here that you can just run and experiment. So these are actually now running in the real ScalaFiddle server. So again, you can do this. Compiling. Let's see. Is the network working? Maybe not. Demo effect. Maybe ScalaFiddle went down last night or something. It doesn't work. But as you saw, you got the first result anyway, because it gets cached into the CDN, and then it gets served from there. And you can even produce these kind of more complex examples that are built from different blocks. So you can join these as a single fiddle, and when you run it works like this, except the compilation doesn't seem to be working that well. Yeah, could be a network problem, who knows. No matter. But this is a good example of how simple it is to get these fiddles into the documentation. We'll actually cover the details a bit later, which is right now. So how to produce interactive documentation using ScalaFiddle. So the reason I wanted to build this integration system was to sort of improve existing documentation. Because, for example, I really like to see a lot of examples, because it's fine to read all the theory and all that stuff, but examples are really what sort of gives me the best way of understanding how to use a library or some feature. But quite often the examples have to be made quite simple so that they don't get too extensive, especially if they are in a book or even in a web page, just something simple, a few lines of code, not covering all the aspects of the library or the feature, because you can't do like dozens of examples on a single page. It gets too tedious. But if you make them interactive, then you give the reader or the user the sort of chance of actually going and experimenting with all those features. You don't have to present all the aspects of your library. You can just hint them that, okay, go and try out this and this and this. And when it's interactive, people are also learning a lot quicker, because when you do something, you remember it much better than just reading about it. And then you can continue sort of exploring features of the library even beyond the examples. So how does it work? So there are a couple of options. The sort of old way of doing is just create a fiddle in ScalaFiddle, save it there, and link in the documentation. But this is not a very integrated experience, and it's also difficult to maintain the fiddles and the documentation to keep them in sync. You can sort of embed the existing ScalaFiddle into your documentation, but you still have the same problem of syncing. So there's now a new integration.js script, which was released late last year, and this makes it a lot easier to integrate fiddles into your documentation, that you just basically flag pieces of code in your documentation that, hey, this should be a fiddle, and then this script will automatically generate the fiddle there, just like we saw on the Scala.lang web page. And there are a couple of plugins that make this even easier, depending on what kind of documentation generation tools you are using, so you can just use a plugin instead. But even with the integration.js, it's really simple. All you have to do is surround your code with this one div, and then add the script to your page, and this will automatically sort of look into your web page, and it will create the run button there, and when you click the run button, then it actually injects the embedded fiddle right in there at the right place and right size and so on. So this is extremely trivial way of using ScalaFiddle. You can customize a lot of things. You can add dependencies like libraries. You can add sort of hidden code, prefixed code, if you don't want to show all the imports and all that stuff every time. In the example, you can hide it. You can use templates for this. You can set the Scala version if it's 2.11, 2.12, in the future 2.13 as well. You can change different visual parameters, how it's laid out, whether it's light or dark, what's the height should be. For example, here is a sort of vertical layout where they are on top of each other. This works well on more narrow pages, and also on mobile. Actually, the ScalaFiddle automatically changes to this layout if you are on mobile. And if you have a large screen, then this kind of a horizontal layout might be better. And if you are working on the dark side in banking, finance, then you might like the dark theme as well. And then there are plugins for Jekyll and Gitbook that makes it even easier, that you just put these flags into your markdown code, just say that, okay, this is a ScalaFiddle, and you just add the plugin to your build, and then magic will happen, and you will have ScalaFiddles all over your documentation. So this is basically how it was done for the Scala.lang documentation page. So you can use the same parameters, you can define templates and so on to make it even easier. And because, for example, SBT microsites is built on Jekyll, you can use this plugin there. And actually, I have an example of that. So Cersei is a popular JSON library, one of dozens of them. And on the documentation page, on the main documentation page, you can see that there is this single fiddle that probably, well, it runs before I make any changes. But this is an extremely good way of starting to explore the Cersei library. You get this good example right here in the documentation. You can start experimenting. What if I change these things to something else? How will it actually work? And if we look at what it takes to actually get the Cersei documentation to this place, so this is the markdown file, and the only thing you see here is these couple of these ScalaFiddle tags. So if we look at the raw version that doesn't have all these fancy things, you can see that this is actually all you need to do to get stuff running. Well, it's not exactly all you need to do. You still have to go and add something into the build file as well. Let's take a look at that as well. So where are the settings for the? So here are the microsite settings. So we can see that we add some ScalaFiddle. Well, where did it go? So we add the Cersei dependencies here, and because we are using SBT, we can refer to the version variable directly in the string. So we generate configuration for the documentation generation quite easily. And probably the ScalaFiddle plugin is somewhere mentioned as well to make the Cersei use it. So this is quite easy that if you are building libraries and you want to integrate some fiddles in there, you can just go on and start using these plugins. There are a couple of examples out there already that are doing it, so you can just go and see how they do it. Or ScalaFiddle itself also has some kind of a short documentation in here that you can just go and check out that how to do all these things quite easily. All right, moving on. So just a few ideas about the performance. So it's really fast. That usually, like you saw, you don't even notice the compilation cycle if the example is quite simple. So it's typically under half a second. So when you press compile, you get the results in under half a second. Actually, the compilation time is typically even smaller. There's always these network delays and other things that take some time to transfer the results to the browser. I'm actually tracking the individual compilations and how long they take on ScalaFiddle.io. So this is a snapshot from yesterday, and for some, usually the sort of baseline usage is about 50 to 60 compilations per 10 minutes. So that's like one compilation every 10 seconds. But for some reason yesterday after 2 o'clock, it went up, and there was like 150, 200 compilations per 10 minutes. But as you can see, the individual compilations don't take that long. It's between 100 and 200 milliseconds. And mostly this is due that if you have any errors in your ScalaFiddle, then of course the compilation doesn't take that long because it will bail out as soon as it finds those errors. But let's say it's fast enough for all kinds of purposes. It's faster than running things locally. And the reason why it's fast is that it does a lot of caching on different layers. As we saw previously, that even if ScalaFiddle didn't work, you could still get those results because they are cached in the content delivery network. So the way ScalaFiddle works, it computes a hash of the source code, and then it asks that, okay, do you have a result for this hash? And if it does, then no compilation takes place. And sometimes it's served by the content delivery network, sometimes it goes to a router, but if it's compiled once, then it's there, and it will never be compiled again. So it doesn't matter if your website gets like 10,000 hits per day or something, the ScalaFiddle is not going to be the bottleneck. Only once people start doing interactive stuff, editing code, then actual compilation happens. But even the compilation is really fast, because inside the compiler instance of ScalaFiddle, it does a lot of caching. It caches all the libraries. It does incremental compilation, incremental linking on Scala.js, all that stuff. All the libraries are sort of prepared to be quickly loaded and so on. So it's really quite nice. So a couple of next steps for integration, building more plugins for other documentation generators, adding ScalaFiddles into the existing libraries by just giving them pull requests. That's how it got integrated into Cersei. One other option I've been thinking about is providing this kind of code correctness verification at documentation build time. So now a lot of people are using this tut plugin to do compilation when they are building the documentation to make sure that the documentation code examples are actually something that built, but it's really slow. So using ScalaFiddle would make that process a lot faster. Of course, you are still limited on using it on libraries that actually run on ScalaFiddle.